Okay, which internet this is connected to? Already. Do you have AirPods? Have you brought AirPods?
Yeah.
Better to use to get a better quality.
Pro and all is not good.
Pro and all not required.
So,
Is there Fevikwik? What?
Fevikwik or Cellotape or something.
Yeah.
Otherwise, like that. I came long back now.
It's already live streaming.
Okay.
But you can start the class. You can put it in silent mode. Mobile in silent mode,
Okay.
so that no one will disturb. Otherwise, call will come, so live streaming may get problem. I will call the students here.
Is it like audible? How I will listen from the kids?
Okay, from online kids.
Hmm.
From online kids, difficult to listen.
Okay.
For that, you have to log in through Zoom also,
Okay.
and then they will separate.
Okay.
Like we can send them the Zoom link,
Okay.
and they will hear through Zoom. They will hear through YouTube.
Zoom
But-
send.
But Zoom link if we send, then we can log in through Zoom,
Okay.
and they will unmute themselves in Zoom
Okay.
and ask questions in Zoom.
Okay.
So we can send one second. I will send one second.
Two kids joined.
One is beyond. They will join, sir, because it will
No,
take some time.
actually, like, should I start or not?
Little bit we can wait. Actually.
If you ask them, like, whether quality is there or not, it will correct it. Otherwise, if you want, I'll use that board.
No, this is better, I think.
Okay. Tomorrow I have to learn because I want to take some diagrams also.
So their video will not come.
Okay.
Their only digital board will come.
Okay. But digital board, on digital board we can take it, no?
You can draw something in the digital board,
But we can't
but
take
these things you can't implement in the digital board, no?
These things won't work in digital board. The camera is there, but camera quality is not there. Okay. Shall I call the students here? Yeah.
Yes. Can you open this?
Actually,
840.
okay, I posted already.
You already posted.
On internet I posted.
Okay, then only we can convert. I will delete this.
Recording in progress.
Hello. 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 Is it audible, ma? Hello.
Yes, sir.
Okay.
You need to be this one mute,
Okay.
and you have to speak through. You this one.
Okay. I understood now. Whatever they
Now,
want,
what-
they
what-
can't speak to that, and they can speak here.
Ah.
And if I want to reply to them, and I have to unmute and I have to
No. Directly through.
here listening and okay.
Ah.
Here incoming it is exactly. But you use AirPods, otherwise lot of noise will come.
Yeah, we can turn off the fan and switch on the AC.
Lot of they won't be able to hear you.
Turn off the fan. To hear what you are saying right now. There is a gap of around 5-6 seconds.
Okay.
What you are saying right now, he will hear it after 5-6 seconds. Then he will unmute his Zoom, and then he will reply to you. So little bit time gap. Otherwise, it's all fine.
Right. So let us start aryl halides. Already, like we have discussed preparation of aryl halides in last class, and we will continue the topic and properties of aryl halides. Maybe properties of aryl halides, one of the most important topic. We are going to discuss in detail slowly and pleasantly. So, aryl halides.
Fan, did I tell you to turn off the fan?
This is font size.
Font size is fine.
Aryl halides. Sachin, is it audible? Okay. For me also first time. Okay. So aryl halides. Already we discussed preparation of aryl halides in last class, and that is Sandmeyer reaction. And then what are the preparations we have discussed? Tell me. Sandmeyer reaction, and then comes Boltzmann reaction and direct potassium iodide, and then comes chlorination of benzene, which is an example for electrophilic aromatic substitution reactions. These are all things we discussed already. So now we are switching to properties of aryl halides. In the properties, as usual, the sequence first physical properties. Physical properties. And if you take it this, now, are they soluble in water or insoluble in water? Tell me, aryl halides. Soluble or insoluble?
Insoluble.
Insoluble in water. And this is something which the basics. Insoluble in water. Why they are insoluble in water? Tell me. Alkyl halides or aryl halides, why they are insoluble in water?
Form hydrogen bond.
We already discussed, right? In last class.
Form hydrogen.
Alkyl halides, though it is having a polarity, but it is not sufficient enough to form hydrogen bonding with water. So any organic compound which could be able to form hydrogen bonding with water, which can able to, which will be dissolving in water. So it is insoluble in water due to the absence of hydrogen bonding. with water. The interactions are not sufficient. That's why it cannot dissolve in water. But soluble in organic solvents. Organic solvents. What are the organic solvents we have? CCl4, benzene, etc. This is general knowledge anyway, so basic things. And we will switch to chemical properties now. Presently you just learn these things, and after the chemical properties I am going to explain, which is very very important, and you should be more cautious about that. And then the second one, melting points and boiling points. Of course, they will be having higher melting points, boiling points compared to their corresponding hydrocarbons due to polarity. There is a polarity which will bring the dipole-dipole interactions, which require extra amount of energy to break the interactions. So that's why more temperature is needed. Melting point and boiling points will be higher side due to dipole. Now, one very interesting point here. If I take dichloro things, if I take it like this, orthochlorobenzene, dichlorobenzene, and then metadichlorobenzene, and then paradichlorobenzene, if you consider, these are the three isomers I am giving to you guys. It's a basic NCERT concept, very important also. So if I am taking melting point, this is structure 1 and structure 2 and structure 3. So I want to consider melting point. So most important and interesting point. What is the increasing order of melting points of these dichloro derivatives of benzenes? Can anybody guess it?
Para will have least.
No?
Para will have least.
Para will have least. Is it so?
Para will be most.
Para will be
highest.
highest. What is the reason, Varsha?
Symmetry, so it fits in a crystal lattice pattern.
Fantastic. Last time, actually, like most of the people will feel that para-dichlorobenzene, if you take it, dipole moment is 0. Of course. Why dipole moment is 0? The electron cloud movement is like this, and this is downward direction. People will expect, means this will have lesser volume, lesser melting point because of dipole moment is less. But very important thing, melting point meaning what? What is the meaning of melting point? The temperature where? Tell me. Solid gets converted into liquid. So solid, starting material is solid, solid to liquid. So in solid, the packing of particles matters a lot. Getting it out? Because the van der Waals force of attraction is higher side because of solid. But within the given space, how effectively the particles are adjusted. So if it is more symmetrical meaning what? Like kind of atoms, molecules. So that like kind of molecules can club together in a sequential manner, in an effective manner. Because of that, packing of crystals will become more efficient, which leads to increasing density of the crystal. So if you take it in this room, all are like same kind of people. Means like diamonds, everything. So then what will happen is you can systematically arrange those molecules within a less space, more particles will fit into that. If you are taking like zigzag manner, it's not a symmetrical molecule, then there will be some voids. Voids means what? Empty spaces. They won't fit properly. Then what will happen? Which will leads to decrease in density of the crystal, and stability of the crystal will be less, easy to break. Point clear? So whenever a melting point, if they are asking in our chemistry, you have to consider symmetry. That's very important. Sir, in what way they will be more symmetrical, sir? So they can align properly here. The particle can come close enough, so which this is a more symmetric due to the symmetrical structure. So efficient packing. So that efficient packing will leads to the increasing density of the crystal, and because of that more amount of thermal energy needed to break that extra interactions, and due to that melting point will increase. So melting point order, if you take it, which is the highest, tell me? Para is highest, and then comes these two, one and ortho and meta. How will you like identify? Means how will you like identify the highest higher melting point compound? Based upon what criteria you will decide which compound has got the more melting point in case of ortho and meta, because there is no symmetry. Neither meta nor ortho has got symmetry. So now melting point will be decided by which parameter?
How they interact that point. Like, less hindrance while interacting means it is more efficient.
So we have to rely on dipole moment. So here in these two, which one will have more dipole moment? When theta is less, dipole moment will be more. That you guys know the cos function now.
Yes.
Here is what? Here 60 degrees angle only now. You can extend it, right? You can extend it these lines. You can identify the 60 degrees angle. How the 60 degrees angle came? You guys know or not?
Yes.
Now if you cut it into the two lines from like top and then this ortho position, their angle is 60 degrees. That's center of that hexagon. Getting it all? Is that clear, Sri Krishna? So now in these two, which one will have more dipole moment?
First one.
First one will have more dipole moment. So because of that reason, 3 is greater than 1 is greater than 2. This is a melting point order. This is due to symmetry. This is due to dipole interactions are there. Do you understand this point? Should I write it clear sentence, or is it fine that like in a crisp way? Is it okay? Can you able to construct the sentence? Even if I say joke also, notes is meant for your comfort. So whatever relevant joke comes also, you can write it in the notes. So after reading that, you should recollect, you can correlate with the concept. That's what. So notes is not like I'll write it like neatly, sir. You won't get Nobel Prize for that. Notes is for your comfort. So right. So now let us take it. This is the point. Next boiling point. Let us consider. Tell me boiling point. Boiling point when it comes now. So again, dipole interactions you can consider. So which one will be having higher side? Almost like they will be showing similar boiling points because molecular weight is same. So in that almost close enough. So if you see the data here, one is higher side due to greater dipole moment, and people expected that 3 will become least, but 2 Kelvin's temperature because of this little packing that is data related. So this 3 is greater than 2. So boiling point alone little. Dipole moment you can take it, but sir, dipole moment for para is completely zero now. But like here, when the particles are coming closer and closer in liquid, a slight impact will be there. That's why 2 Kelvin's temperature, the very close boiling point is. So very important thing here, melting points why para is higher. This is what the question they will ask you. Due to symmetry. That's all. Next, density. Tell me. Density. Fluorobenzene is less than or like phenyl fluoride. Why? What is the reason? Tell me. What is the reason?
Higher molar mass.
Higher molar mass, more density. Right? Is that clear? Now, let us go to chemical properties, most important one. And bond strength, which one will be highest? Tell me. Phenyl fluoride, phenyl chloride, phenyl bromide, phenyl iodide.
Phenyl fluoride.
Phenyl fluoride will be having greater bond strength because of shorter the bond, stronger the strength of the bond will increase and bond is becoming shorter and shorter. Right? Right. So now let us move to the one of the most important and interesting parameter. Chemical properties of aryl halides. Chemical properties. Pleasantly you can listen, you can raise whatever the doubts you have. Even the kids who are listening through online also, you can raise your doubts. Very important, these 3 segments I will teach, very important. You can expect one question for sure. 100% I can guarantee, whichever interest exam. 3 segments I am dividing entire this chemical properties. Slowly, with a sequentially we will move and we just listen carefully. First segment is in this chemical properties. Nucleophilic, aromatic, substitution reaction. Nucleophilic aromatic substitution reaction. Second one is electrophilic aromatic substitution reaction. Electrophilic aromatic substitution reaction. And third segment is reaction with metals. Chemical properties of aryl halides categorized into 3 types. One is nucleophilic aromatic substitution reactions. Another one is electrophilic aromatic substitution reactions, and then reaction with metals. Right. Now let us start the proceedings with nucleophilic aromatic substitution reactions. You can also represent SNAR, aromatic nucleophilic substitution. So we already discussed this nucleophilic substitution reaction in alkyl halides with SN1, SN2 and SNI mechanism. So what is the meaning of nucleophilic substitution reaction? Pranesh, name itself indicated.
The nucleophile will be substituted in the aromatic compound.
So the substitution of halogen atom in alkyl halides or aryl halide by a nucleophile. So the name itself indicated. But here aryl halides, very important point. I already taught you guys. So let us talk about aryl halide structure, which we discussed already. Let us consider this is the aryl halide. These aryl halides, already I mentioned it. Will it undergo nucleophilic substitution reactions under normal conditions? Under room temperature and pressure, can it undergo? Replacement of X, is it possible here under normal conditions? Impossible. What is the reason? Tell me. Aryl halides can't undergo nucleophilic substitution reactions. Substitution under normal conditions. Under normal conditions. Why it can't undergo nucleophilic substitution reactions at normal conditions, sir? What is the reason? For that already I taught you guys this lone pair of halogen atom. Not only halogen atom, in our chemistry, whenever you have a double bond, adjacent any atom you keep it with a lone pair. So immediately that lone pair starts overlapping with it will involve in resonance with the adjacent pi bond. So why, sir? Why resonance has to happen? That nicely they can lead their life with that atom now. Why that fellow has to come and involve in resonance? In what way it will get, like system will get advantage with that? When electron clouds are moving throughout the system, more number of nuclei will experience that attraction force. Whenever net attraction force increases, potential energy of the system will decrease, and the decreased amount of energy only will be released by the system, and system will always move towards stable state. So everything in the universe tries to exist in more stable state by losing the potential energy in all possible ways. So here also this lone pair starts interacting with this pi bond. Of course, you guys know this thing, the resonance structure. Now if you write resonance here, so this is X plus and this is minus, which we discussed already in resonance. And then comes again one more resonance structure, you can write it here. This negative. Tell me, Mokshita, what will happen? Tell me, this negative will attack here and this pi bond will be shifted to para position. Very good. So this is the negative, and then comes again this one will attack here and bond it will shift. So you will be getting what? Tell me.
Negative in meta.
Right. Negative in ortho position, and then like this double bond X here plus. Again this negative charge will come and attack here and bond it will shift. Is it visible to you guys?
Yes.
Right. If you take it this, you will be getting again normal position, just a mirror image of. So overall, if you take it, I can show you this one also. This is the benzene, right? So you have a carbon here, carbon here, carbon here, carbon here, carbon like this, a flat one. And above and below you will be having electron clouds. So this is, you can take it your chlorine, halogen, and any halogen atom, and which will be on the plane, aligning like this. So now this above and below you will be having electron clouds. Pi bonds will be always lateral overlap. Getting it all. So now when I am taking like this cloud starts interacting here, and then next this region electron cloud will develop. Now again this one will attack here and it will send to the down. Here negative charge. Again it will attack here and this ortho position negative. Again it will give and it will come. So this process, because of this process, electron clouds is spreading entire the system. Just like a sandwich, you can take it. This is the skeleton structure. Electron clouds will be above and below. So this hexagon ring is sandwiched between two pi electron clouds. Which one is above, another one is below. Are you able to visualize? And now I want to break this. If it is a single bond, I can break it nicely. But when this starts overlapping here, so if you take it as overlapping, also fantastic phenomena. Now lively you can. Again I am saying, you should command organic molecule. Should direct that like electron clouds. You can dictate that. That kind of concepts you should learn. So when you take it this above and below electron clouds, and these parallel clouds will be again interacting with which are parallel clouds. Do you understand? Hydrogens on the plane will be there, above and below. These are the things actually. These things starts interacting through sidewise. So that is how it will form a pi bond. Getting it on. So now normally it is a single bond, means you can break it very easily. But that extra interaction through pi bonds, through resonance, whatever it is developing, that extra interaction above and below, like this. So with the ring is strongly connected, so that partial double bond character will develop. So breaking required, normally single bond, right? But because of the resonance, partial double bond character, the extra interaction which is developing, which will connect that halogen atom to the ring very strongly. So which required huge amount of energy to replace that X. That's why at room temperature, the internal energy is not sufficient enough to break that interaction. single bond and extra interaction. That's the reason it won't undergo nucleophilic substitution reactions under normal conditions. We can explain two reasons, very important reasons. So you can write it here. Due to following reasons. Due to following reasons. First one, you can write it partial double bond character. Partial double bond character due to due to delocalization of lone pair of halogen into benzene ring. So otherwise you can say simple thing due to resonance. So because of this delocalization, already we have discussed here, there is partial double bond character is developing like this. So this is the partial double bond character, which makes difficult to break that bond. That's the reason reaction will not take place in aryl halides. RX case directly like X you can break it, only single bond. Do you understand this point clearly? No. Next. Due to unstable intermediate, unstable carbocation, with the formation of unstable carbocation. Sir, it can undergo SN1 mechanism, no, but it is unstable carbocation intermediate. Sir, why it is unstable, sir? You can take it X if you remove it. Is this stable? Is this carbocation stable? What is the hybridization of this? What is the hybridization of this thing? SP hybridized carbon. SP hybridized carbon. Why SP hybridized carbon? Sigma bonds how many? For this fellow, sigma bonds 2. There is no lone pairs. So number of sigma bonds plus lone pairs will be considering for hybridization process. So now we have only 2 sigma bonds, right? So SP carbon, like what will be the shape? Tell me. Should be linear. But is it possible to maintain linearity like this in ring? No. So it has to, from 180 degrees, it has to bend like this. So it will experience loose angle strain. And more than that, percentage of S character here is higher side. More electronegative atoms should not carry positive charge. So here, more electronegative sp hybridized carbon, sp hybridized carbon carrying positive charge, which is unstable. Because of these two important points, so aryl halides cannot undergo nucleophilic substitution reactions under normal conditions. Point clear? Raise it if you have any doubt. Now we are going to move an interesting topic. Is that clear? Yes. However, yes, aryl halides cannot undergo nucleophilic substitution reactions under normal conditions. But however, if you use vigorous conditions means high pressure, high temperature, and one more important point, the presence of electron withdrawing groups at ortho and para positions makes that compound to react, makes that compound to undergo nucleophilic substitution reactions. So can you give examples and evidence, mechanism, different types of questions, everything, which is it? Our question also, even NCERT book they get with mechanism. So very interesting and important topic. So we will discuss in detail. Now, can I rub this thing? Sachin, is it audible, Ra? Dharani? Hello? Ma, is it audible? Hello? Okay. Oh. Right. However, the aryl halides can undergo nucleophilic substitution under following conditions. Under following conditions. Under following conditions. What are those conditions? Explain, sir, with evidence. I'll explain. First one, the presence of electron withdrawing groups. Electron withdrawing groups. What are the electron withdrawing groups? There must be at least few groups. Moksha. Electron withdrawing groups like NO2. NO2 is electron withdrawing, electron releasing. Withdrawing group. And then C double bond O groups. And then C triple bond N cyanide groups. And even SO3H groups. So these groups will make the reaction to happen. In what way it will contribute, sir, for aryl halides? Nucleophilic substitution reactions in aryl halides. In what way these parameter or this particular parameter will contribute? And I am going to explain in detail with mechanism. Argue with me. Don't compromise 0.1% also. Raise it, whatever the doubts. Now, so the presence of electron withdrawing groups like NO2, CO, Cl, and sulfonic acid, etc. at ortho and para positions to the halogen group. I'll explain in detail. This is the first important condition. And then second, in presence of strong presence of nucleophile, you can say, in presence of nucleophile which serves as strong base. Strong base means you have to choose a nucleophile which can serve as a strong base as well, and high temperature and pressure conditions. We will use high temperature and pressure to break that C and X bond. Why we need high temperature and pressure, Sri Krishna?
We can break the bond.
Why like we have to supply high? Normally itself we can break now. What parameter? The lone pair is involving in resonance. That's why vinyl halides also same thing. Come on, even the same concept you can apply for this thing also. Vinyl chloride also. So any halogen atom which is connected to the double bond fellow will be developing a partial double bond character, so which makes the bond break difficult. Is that clear? Right. So now let us move toward mechanism of nucleophilic aromatic substitution reactions. This mechanism we divided again into two types. So first, write it now. First mechanism, very important. Addition followed by elimination. Addition followed by elimination mechanism. Addition followed by elimination mechanism. Right. All of you listen slowly and pleasantly now. I'll explain. You can stop writing also. Explore it rather than simply writing. Just explore it pleasantly. Now if I am taking here x, my aim is to replace this x by some nucleophile. I want to take some nucleophile. Generalized way I am taking. OH minus you can take it. Cn minus you can take it. This kind of nucleophiles if I am taking. So here the condition what I told, tell me first condition. The presence of electron withdrawing groups at ortho and para positions. Why these positions important I am going to explain. If you increase more number of electron withdrawing groups, reactivity also will be higher side, which is very important question. So when I am taking this, very easily that X can be replaced by nucleophile. So how it will happen now I will explain with mechanism. This is the target and this X minus 1. So replacement of this X by nucleophile. How that mechanism sir? First step, attack of nucleophile on the carbon where like that X is attached. Now when I am taking first step, this is X, that is the rate determining step, a slow step and rate determining step. It will attach like this to this carbon and you have what ortho and para positions, electron withdrawing groups. Like this you have electron withdrawing groups. When I am taking this, now this is the slow step and which is also known as rate determining step. Can anybody guess it why it is slow step? Anyone in the class? Why attack of that nucleophile, the first step on benzene ring is slow step and rate determining step? Why it is slow? Why that activation energy is higher side? Can you predict it?
Already it's resonating.
Already electron density on benzene ring is higher side. But the electron clouds are there above and below. When you bring that nucleophile close to that, will it get repulsions or attractions? Repulsions. So against the repulsions you have to push it. Means you need to supply more energy. That's the reason first step, attack of nucleophile on the carbon where like that X is attached. So that is the rate determining step. So the moment when it is attacking now, then what will happen? Kaushal, tell me this pi bond which side will shift? Can you tell me more?
Right side.
Fantastic. Right side. So then automatically you will get what? Tell me. Which position you will get negative charge?
Right side. Ortho.
This is the position you will be getting negative charge. Now intermediate is what? Tell me. Intermediate, is it carbon ion or like carbocation?
Carbocation.
Is it carbocation or carbon ion? Carbocation means carbon with positive charge. Here carbon with negative charge. Carbon ion. Carbon ion. So now intermediate like will be stabilized by what? Tell me. This carbon ion. Carbon ion stabilized by tell me Electron withdrawing groups. Whenever intermediate is getting more stable, no, reaction feasibility will always increase. So that position where that negative charge is coming, now that position, this electron withdrawing group will be helpful to stabilize. I already taught you guys, when you have got carbon ion, carbon with negative charge, if you take any group which is electron withdrawing, then automatically which will leads to stabilizing carbon ion. It will stabilize the carbon ion, because in our chemistry, whenever charge intensity getting suppressed or like it is decreasing, the system will always get more stable. So that's why when you have positive charge, somebody who is releasing electrons and the positive charge intensity gets decrease. So system want to maintain neutrality. Getting it on? So when you have a negative charge, then somebody is taking means the negative charge getting decreased. The intensity of the negative charge gets decreased. So which will give us stability to the system. So whenever intermediate is getting more stable, system will always be can react easily. The spontaneity of the reaction will increase. So anywhere in organic, if they are asking reaction which is major product or minor product, or which reaction will happen faster and all. So the only criteria is intermediate stability. Right. Again, when it is undergoing resonance, again which positions it will come tell? Which positions this negative charge will come? It will attack like this, and the bond will be shifting like this. So the pi bond will be coming down. So you will be getting what? Tell me again. Which position you will be getting negative charge? Which position you will get negative? This is X, and then nucleophile will be there, and you will be getting here. This is a negative charge. Again, this electron withdrawing group, like NO2 groups, they will keep it. Which will be more stable. And then here you can take it again, electron withdrawing group. And again this negative charge, it can stabilize. And this negative charge again will attack here, ortho position will get. That's the reason I mentioned that whenever this so formed carbon ion, when the negative charge is developing at ortho and para positions, at that positions, if you keep electron withdrawing groups like cyanide, NO2, especially NO2, they kept on asking questions regarding this concept. So when you have NO2, so NO2 like keep on withdrawing that electron clouds, so that intensity of the negative charge gets suppressed, and it will give the stability to the system. That's the reason that first point I told, and this question they kept on asking. Which of the following will be more reactive towards this aromatic nucleophilic substitution? Like that question will come. I'll be giving like one example question also. So meanwhile we'll finish off this, and the next resonating structure will be again this is electron withdrawing, and here again electron withdrawing group if you take it, which will be stabilizing nucleophile, and this is X. So finally you will be getting the intermediate like this. You can take it X here, nucleophile here, ortho position to ortho position, negative charge will come. So the presence of electron withdrawing groups at those positions where the negative charge getting accumulated, and they will be helpful for the stability of intermediates, which makes the reaction more spontaneous. Is that clear? Paka? Clear? Right. Next, second thing. Second step. Removal of halide, halogen atom, or elimination. This is attack of nucleophile means what? Are you adding like a addition followed by elimination mechanism? So first what you have done, tell me. You are adding the nucleophile on ventilator, right? So that's why addition followed by elimination reactions. So like you can say elimination of halogen atom. Elimination of halogen atom. When you consider this, simple topic. This is faster, and you have X here and nucleophile here, and you have got electron withdrawing groups. Imagine like any one of the structure, I'll take it. Think and tell me now what will happen. It's a very, very easy concept. It's a fast step. Ring has to complete. Sri Krishna. Stay strong. Just cool way think, man. Believe me, and like move forward. Tell this is a negative charge. I want to complete the benzene ring. I got negative charge, right? So what will happen? This will attack this position negative. So this position should get what? Positive. Then like a ring will get completed. So automatically what will happen? X will be leaving as X minus Cl minus. Hello. Hello. Lagging in YouTube. Hello. Still same problem? Ask like Vishal sir, Prabhulas sir. I'm not like very strong in technical. Are you able to see that? Gautam? Nivedita? My handwriting, if you want me to write slowly, I will write it, because after like almost 2.5 3 years I am writing on the board. Is it? Can you able to understand, or like it look like Urdu language? Again, like I should not use in YouTube like different. Those people will get offended. Okay, now it is. Amma, is it okay? Are you able to see? Nivedita, can you able to understand, ma? Basically, my handwriting is worst, and now like it became even big. Are you able to understand that? Should I write slowly? Okay. So this 2,4,6 trinitrochlorobenzene, if I am considering with NaOH, aqueous NaOH, if you take it now, just small heating, like it, not little like warming is enough. Actually, if you increase NO2, only one NO2 is there, means you require more temperature. If you increase second NO2, temperature required will be very less. And third NO2 also, if you introduce, very less. Reason? Good. When number of NO2 groups on benzene ring increases, rate of reaction will increase. Why it will increase? At ortho and para positions, whenever intermediate negative charge carbon ion comes, NO2 starts stabilizing or destabilizing. It's stabilizing. So that's the reason. So can you guys guess it? Nivedita, can you finish off this? Can you predict? Na plus OH minus is there. So now which is nucleophile? Can you able to predict it? Just stay strong and say the answer. Hello. Tomorrow 10 to 20 seconds will be here. Now I think like it is completely stopped. You guys have to guide me, that's all. I never like. Sachin, is it audible, Ra? Gautam? Okay. Right. So tell me about this one. Here you guys write the mechanism for this. So this is picric acid. Tell me about it. After 10 seconds. I should not mistake. Okay. Amma? Board is not clear. Board should not be clear. I should write something now. How it will be clear? Is it clear now? Now? Now are you able to see? Hello? Okay. Okay. Can you able to see or not? Hello? Okay. Is it, can you able to manage, or should I call like, should I stop here? Hello? Okay. Gautam, I think like you can change the quality of video, right? Okay. Fine. Next. So, can I rub this thing? Kaushal, is that clear?
Yes, sir.
Now, I'll just give you some example question. Just tell me the one. Arrange the following in the increasing order of nucleophilic aromatic substitution. This is the question. So now, let us take it like this. X These are the 6 compounds I am giving to you guys. You have to arrange these 6 compounds in the increasing order of the reactivity of these compounds towards nucleophilic aromatic substitution. So 1, 2, 3, 4, 5, 6. Can you able to follow? Gautam, can you tell me, Ra? Are you able to like see the structures properly, or should I write it slowly? Okay. Okay. So increasing order, the least one, which one tell me? Least one you can easily identify. Mokshita, can you tell me?
6.
Least one, least reactive.
Yeah. 1.
NO2 presence, will it increase reactivity or decrease reactivity?
Increase.
Good. Why it will increase reactivity?
So, it will decrease the electron density.
Good. The negative ion, whatever carbon ion intermediate, can be stabilized by
Electron
withdrawing groups. And what is electron withdrawing group? The presence of electron withdrawing group pakka will increase the rate of reaction towards nucleophilic aromatic substitution. Now, so one is least, and then comes position matter now with the mechanism. So now mono substitute. Only one NO2 groups we will consider. One NO2 group, position matter. So now one NO2 should be at ortho and para or meta. Which one will contribute for the stability of carbon ion relatively higher side? Ortho and para. Reason? During delocalization, during resonance, negative charge will be on ortho and para positions only. Clear? So now in these two, which one will be higher side? Impact. Where it will be higher side? Forsha, can you tell me? This one are very easy questions to ask. Oh,
3 will have lesser, 2 will have greater.
very good. And then next, in these two,
Uh,
now dice are tricky.
5 will have greater, 4 will have lesser.
Fantastic. What is the reason?
Because 4 has electron withdrawing group at meta position.
Fantastic. Good. Now next,
And then 4 and then 6.
these are questions. They ask 4 options actually. You have to identify. Whichever option you have got NO2 groups, cyanide groups, or ortho and para positions, that will enhance the rate of reaction, increase the rate of reaction. Clear, Ridhushri? Is that clear? Okay. Next.
So can you what are these?
Oh. You can operate it actually. Too much it is. Okay, next.
So why would 4 not be less reactive than 5?
4 is less, sorry.
Yes.
4 is less. One less than, 3 less than, 2 less than, 4 less than, 5 less than 6. Yeah. 4 is less than. Right, next. Can I go to the next point? Same mechanism you can find in NCERT book also. Right. Next. Next. Second point. Elimination followed by addition, or you can say Benjamin mechanism, very important. Again, interest point of it. Second mechanism, first elimination, followed by addition mechanism. So there will be intermediate called Benjamin. So it's a Benjamin mechanism. So how it will work, sir? So very interesting again. So let us consider this time there is no electron withdrawing groups at ortho and para positions. Obviously, which will make that intermediate carbon ion less stable relatively. In presence of electron withdrawing groups, carbon ion formation will be more feasible because that will be assisting the stability of carbon ion. Whereas in this case, due to the absence of electron withdrawing groups at ortho and para positions, which cannot undergo addition followed by elimination mechanism. So in this case, for example, if I take it chlorine, chlorobenzene I take it, and then when it is reacting with sodamide, I already taught you guys I mentioned in second point that it should be a nucleophile and as well as very strong base also, and you are heating, and in fact you can mention it Na and H2 in ammonia, liquid ammonia actually. So you can maintain normal temperature. So ammonia means sodamide, Na plus NH2 minus in ammonia liquid we will take it, and it's very simple, ma. Predicting that product is very simple. Moksha, can you guess it?
Cl
Perfect. Then
NH.
nucleophile is NH. Cl will get displaced or replaced by NH2 minus. But it is not that NH2 minus straight away it will attack, but it will follow a typical mechanism. It's a very important. It's called Benzyme mechanism. For example, if I take mechanism, I may just put it a star carbon. This is. I'm just labeling it. I'll explain why I'm labeling it. First step, extraction of beta hydrogen. Let us consider this is the carbon and you have got hydrogen here. Can anybody guess it? It's a very interesting concept. NH2 minus, if you take it here, NaNH2 will be ionizing as NaNH2 will ionize as Na plus and NH2 minus. Point number 1. Then after that, this NH2 minus captures H plus ion. It will break here and you will be getting like H plus ion here. Then NH2 minus, after capturing H plus ion, it will go out as ammonia thing. So now here what kind of charge will develop? Tell me. Negative charge. And that negative charge will attack on the next carbon and then automatically this Cl minus will join with Na plus. Are you able to understand, Sri Krishna? Raise it 1000 times also. Full freedom to you. Now let us take it this. Then what will happen? In addition to this, one more pi bond will generate. So now the Cl minus Na plus ion will club together. NaCl and NH2 minus capturing this NH. First step, Benzyme mechanism. Benzyme. See, generally you guys know already, like triple bond is there means what we will call? Alkyne. Ine only na. So benzene ring like triple bond means benzene. But sir, 6 means any cyclic compound triple bond if you keep it, it is hybridization is sp hybridization. It will experience a lot of angle strain because it should be straight. It cannot bend like this. The bonds. Getting it or not? So now, in what way it will be stable? So most important question. I'll explain the structure, how nicely it will pour in. So this is called benzene. This is an unstable intermediate only. So how it will exist, you know? Very interesting. It is a diradical. It will exist as diradical, meaning this pi bond will break like this. Most important point this is, and this location will be filled with one electron, and here one electron. So this orbital again sp2 only. This also sp2. So if you keep it, this is fully sp carbon. If you keep it now, then what will happen? Aromaticity will get disturbed. Getting it or not? So that's the reason that the third bond in benzene will break homolytically. Previously in benzene, how we discussed, tell me here, if I am taking this, you know, here this location, hydrogens are there, nicely hydrogens are there. Now I am just keeping one more bond here, but that bond, a triple bond, no, homolytically it will break. So one electron will be here, another electron will be here in sp2 carbon itself, sp2 hybrid orbital itself. So now what will happen is this one sp2 hybrid orbital, this is also sp2 hybrid orbital, sidewise they will overlap. Generally pi bond, how it will form? Tell me. Pure orbital will form pi bond. Hybrid orbital always is forming head-on head overlapping sigma bonds, which we discussed already. In variety, in benzene intermediate is to retain the aromaticity of benzene, so that third bond, whatever like it is generating during this mechanism, will break homolytically, which leads to the formation of two odd electrons. That's called as diradical, which like, you know, sidewise it will interact, sidewise. So that's the reason one or more than one J8 bonds, they ask many times this question. In benzene, that extra bond is generated due to the overlapping of two sidewise overlapping of two sp2 hybrid orbitals. It's the most important thing. These two starts overlapping. This is the overlapping extra pi bond. So it will exist as a diradical. So on the plane nicely, the two electrons on the plane will be there. Above and below the clouds will be spreading as it is. So it will not disturb the aromatic ring. Now instead of hydrogen, you put it as, instead of hydrogen you put one electron, radical, odd electron you put it, that's all. So there will be some, this nucleus will attract this electron. The side bond, how it will form, you have got here one electron, this location one electron. Now this nucleus, this carbon nucleus will have inside that protons. The proton starts attracting this cloud. It will like move in between that, and then this side also the electron clouds will be attracted by this nucleus. So these starts like keeping like this close. So both the fellows will experience the attraction from that common cloud. That is what sharing of electrons we discussed. Variety is, it's not head on head. It can't be a head on head. So that is what sp2 only. So there is sp2 sidewise bond will happen in benzene, which maintains the diradical nature and which will be an asset for aromatic stabilization of benzene. Is that clear or have any doubt? Question?
Yes.
Argue. Put it like some questions. Clear? No. Is that clear, Sachin? Dharani? Gautam? If you are not understanding, later you can call me. Manasa, are you there? Okay. Right. This is the first step. Elimination happened now. So now I got the interviews. Now, if I am taking second step, now addition. Right. Like this we have. I'll just keep it star here. Okay. Just I'm labeling it. I'm labeling this. Now soda made I'll take it. NaNH2. NaNH2 I'm just taking it. Varsha, can you tell me NaNH2 if you take it, how it will split, and can you able to predict it?
So it will split as Na plus and NH2 minus.
Fantastic. This NH2 minus can go and attack here, and then bond will shift either this direction, or this NH2 minus can attack and down also. There will be two chances here for NH2 minus because it's a symmetrical, right? Triple bond is symmetrical. It can attack either from top or from bottom. But sir, anyway identical? No. Both are same only? No. Both are same, but I just labeled it to explain to you guys like it is. There are two chances, either from top argument or it can come from bottom. Is that clear? Now, if it is attacking like this, negative charge will come like this, and NH2 minus is here, will attack. Can you guess it after forming negative charge? Kaushal, can you try for it? Ammonia, if I am taking like this, and this nitrogen will pull the electrons and it will donate electrons. Hydrogen and nitrogen, which is more electronegative?
Nitrogen is more electronegative, sir.
Oh, yeah. So automatically what will happen? H plus ion and then
N minus.
so bond will break and the C minus will capture whom, tell me?
H plus.
H plus ion, and it will kick out
NH2.
NH2 minus, and NH2 minus again combined with
Na.
Na plus ion, so soda bond will regenerate. So you will be getting what, tell me? Like this. The top carbon will be getting star anyway. Why you are representing that, sir? In case of substituent like halogen compounds are there, na? My benzene there are substituents are there means it will become significant. So that's what I want to like explain this. So if NH2, the nucleophile is attaching to the carbon where previously halogen is attached, na? Same carbon, if it is attached, no, that kind of thing we'll call it as ipso product. Ipso product. IPSO, ipso product means you can remember like this. I stands for identical. So X containing carbon is the same carbon that nucleophile attached means that's called as ipso product. Ipso. Clear? And then comes if you take it another NaNH2, if it is attacking from here sidewise, the down neighboring position, if it is attacked now, then what will happen? Tell me. Negative charge will develop on whom? That labeled carbon only, na? Ima. So now again same story. After this, what will happen? NH2 is, it will take electrons and creates positive charge and hydrogen, and when that negative charge starts attacking on this H plus ion, and then what will form? Tell me. What will form? This is the star NH2 like this. So this, sorry, is down. Yeah, H2 down. So this is adjacent if it is forming now, that we will be calling as Cine product. CINE. Cine product. So one is ipso product and the one is Cine product. Like this, first elimination followed by addition reaction will take place, which is intermediate is benzene. So many entrance examinations, even bits, these kind of things also they are asked actually. So which of the following cases, in elimination followed by addition, which intermediate will generate? So benzene intermediate, which will be aromatic in nature, existing as diradical. And in that intermediate, there is sp2 sidewise overlapping will happen, which leads to the formation of third one. Clear? So because triple bond inside benzene ring is not at all stable, they can't exist like this. Sidewise overlapping not possible. It will destroy the aromatic character. So that's why they will be existing as diradical. Fine. Can I clear this thing? Can I rub this thing? You can, if you want, you can take time. Okay. Time over already. 15 minutes. Right, next. Can I move to the next point fastly? Can I rub this? Right. Sir, what kind of questions they will ask in exams? Can you explain, sir? Yeah. For example, you tell me which of the following will not undergo aromatic nucleophilic substitution reaction. Like that the question will come under normal conditions. Like that. So chlorine CH3 will be there. So the same question I think last time Gautam asked. Gautam, can you tell me now? Answer. Hello. This can undergo. So why circle? Why this can't undergo nucleophilic substitution reactions? Moksha, can you try for it? Ima. What is the first step we discussed? Soda wine. Addition or elimination? I talk about this one. Second mechanism. Elimination. In doing elimination, like NH2 minus is capturing what? H plus ion it is capturing, and NH2 minus is going and capturing H plus ion. Now in which case like you have got H plus ion, tell me. In which case you don't have H plus ion. Here you have got H plus ion adjacent to chlorine containing carbon. So nicely like these two can go out and benzene can form. And here these two can go out. So definitely they will undergo nucleophilic aromatic substitution. Sri Krishna, third case, can it happen or not? Tell me. It can happen. Fourth case, reason? No beta hydrogens. No adjacent hydrogens. Can't form benzene. 4 options. Strike question. Many times they ask this question also. Sir, but it can undergo addition followed by elimination. No. But CH3 groups are
Bulky.
bulky, unlike it is electron releasing or electron withdrawing.
Electron release.
Electron releasing groups. But we need electron. If NO2 groups are there, then straight away that mechanism it can follow. Do you understand this? So this note down. Sir, can you explain few substitution in substituents are there? For example, CF3 is there. CF3, and here I'll take it X. I'll take it this. Now, if I'm using sodamide in ammonia, so I'll get two products here. Can you guess it? What are the two products? Can you tell me what is ipso product and what is sine product here? What is ipso product and what is sine product? See now, CF3 I am just keeping it. In the absence of CF3, fine. You will have like either all like 6 positions in benzene ring is identical. So it doesn't matter whichever thing you are writing. But now, in presence of CF3, the position of benzene ring matters a lot. Now what are the two products are possible here? Tell me. Either it can triple bond, where it will come? Tell me. These two are will be gone, right? So triple bond will come like this. Now NH2 minus can attack ortho, or NH2 minus can attack at meta position. So now what will happen? Tell me. CF3. So you will have NH2 here. Now is this ipso product or sine product? Ipso product or sine product? Can you tell me this one?
Ipso product.
It's a ipso product. See, if you forget the name now, I stands for identical carbon. Same carbon, same halogen containing carbon. Halogen directly replaced by NH2 na? Ipso. See, previous case, addition followed by elimination mechanism, only 100% what product? Ipso product only. X directly replaced by this. There is no neighboring carbon. There is no benzene. Do you understand that point?
Yes, sir.
Now, after this ipso thing, if you consider another one CF3, you have sine product. Sine product. In this, which is major and which is minor? Can you able to guess it? Very, very important note. Can I explain little more? The same relevant concept only. Why it is more and all I will explain. Sine product is. Now, one important note. In benzene intermediate, mesomeric effect, or like you can say only inductive effect will operate to stabilize the carbon ion. In benzene intermediate, only inductive effect will operate. Sir, why sir inductive effect? Mesomeric effect also can operate? No. See, the thing is, plus M effects and all cannot come. Like this, if you have, like this triple bond thing na, will not allow that cloud to shift on the ring. Already full of electrons, na, the triple bond. So, which will resist. So, but however, these compounds can always like stabilize through sigma, like sigma electrons movement, through sigma bonds, that whatever like groups you have minus I affecting groups can stabilize that carbon ion. So now here, if you take it, inductive effect. So this is the most important question they asked. If I am putting CF3, here sign product will become major and ipso product will become minor. But how it will give major products, sir? Sign products or sine product will become major. Can you explain slowly and pleasantly, sir? I'll do it now. You can ask me also. So if I am taking like this, CF3 I have. CF3 group, is it electron releasing group or electron pulling group? Question. Electron releasing group or electron withdrawing group? CF3.
Electron withdrawing group, sir.
Electron withdrawing group. Because all fluorine starts pulling electron cloud, so automatically CF3 as a whole it starts pulling electrons. So now, can you able to create this equation? I am just giving you a clue. I should get most stable carbon ion possible to lead the reaction more spontaneously. Now I have got like sodamide. So now if I am taking sodamide, you guys know already, it will be splitting as Na plus and NH2 minus. Now which side NH2 minus should go and attack to get the more stable carbon ion? I got two chances here. So either it can attack here, so that bond will shift down, so you get negative charge on
Bottom.
meta position, bottom, and if NH2 minus can attack here, then the pi bond will go to ortho position. In these two, which case you will get stable carbon ion, and one more important thing, always minus I effect will stabilize carbon ion in the system. So CF3 group, already we discussed that CF3 group is minus I group. This electron withdrawing group is a minus I affecting group. Means that negative charge should form close to the CF3 or away from the CF3.
Close.
If it is at ortho position, close. If it is at meta position, it is little away. Already you told us.
Yes, sir. So NH2 would attack at meta position, so pi bond will move.
Fantastic. Proud of you. Very nice. So this one, this is less, and this is more. So why it is more? Because of why it will attack like this. So minus I effect whenever you are taking like this. This is the negative charge, and we have got CF3 group, which is minus I affecting group, and through sigma bonds it can come. So this is the one intermediate I have got, right? Another intermediate, tell me. NH2 minus can. This is path 1 if you take it. And another intermediate is, tell me.
Minus charge at meta position.
Minus charge will come like this, and then CF3 will be here, like this. In these two, if you take it, which is more stable intermediate? Can you tell me, Moksha, slowly and pleasantly? CF3 is electron withdrawing group through minus I effect. Minus I effect means through sigma bonds it will pull the electrons. Now, inductive effect, distance more, na? Inductive effect impact will decrease. If it is closer means impact will be more. So now in these two, which case negative charge will get stability more. CF3 withdrawing. Electron withdrawing groups, will they stabilize carbon ion or destabilize carbon ion? Stabilize carbon ion. So now in which case like it is more stable? This case and this case, meta position and ortho position. In which case CF3 can stabilize negative charge more.
Sir, I think ortho.
Fantastic. Correct answer. More stable. So the negative charge should be closer to minus I affecting you. Clear? Any doubt in this? Sri Krishna. Pakka clear? Next one, what will the product tell me? Major product here? This negative charge will capture who? From ammonia, H plus and it will capture. So which will leads to the formation of CF3. And then here, this is NH2. We have to take it here. This hydrogen, NH2. So this is major product, CN, major product. Similarly, you can replace in place of CF3, OCH3 if you take it also, same minus I effect. CN product will become higher side. Do you understand this point?
Yes.
Clear? And then another note you can keep it. If I am keeping here CH3 and then again chlorine, if I take it NaNH2 in ammonia liquid, if you take it, here one interesting thing, CH3 is, will it stabilize or destabilize? Will it plus I or minus I, that is?
Plus I.
So that is the reason. So here like again what are the products it can come, tell me? This is ipso, almost 1:1 ratio it will be developed. One is 48.5%, another one is 50%, like that it will form. CN product is higher side, here also, NH2 here. Sir, why sir it will be? Both the cases CN product. Here 48.5%, it is practically observed quantity because the CH3 impact is very less, because it can't push that electrons, already full of electrons in the cloud and benzene ring. So on the position, sir, then on the position it can come more, no. So slight steric hindrance it can show. Because of that reason, this alone you can remember 48.5%, this is a 50%. So CN product, both the cases will be dominating. So very important question this also. So comparatively this side if you take it, it is attacking here. Clear? Sri Krishna. Right. For all of you, is that clear, Gautam? Right. So that's all related to nucleophilic aromatic substitution reactions, and then we left with electrophilic aromatic and then reaction with metals, that we will discuss in next class, already 9 o'clock. So you can leave and we will discuss in next class. Concept remaining. Okay. Rishwant, how to stop this thing?